Okay, good evening, good morning, good night, good afternoon. Today we keep going down our matrices path, looking at transition matrices, similar to some other questions that we've done on the channel. So let's kick it off. So imagine that we live in a world in which people are either happy or unhappy. Black and white, be simple, wouldn't it? But the way people feel can change from day to day. In this world, gives you what's going on there, and it sets it out in a diagram as well. So the first thing is, rather than going through those, let's get to the question that deals with them. Construct a transition matrix to describe this situation. We're going to call it T. Okay, so I'll start up here, give myself some room. Always run out of room on these questions that are big. Okay, so our transition matrix is going to have, we know that there are two states. So firstly, identify the state, happy and unhappy. So let's go happy and unhappy. That'll be enough room for my values. And the order across the top is the same order down the side of the rows. So happy and unhappy. Okay. Now we need to pick off the combinations. So 90% of people who are happy today will be happy tomorrow. So this is today, present, and this is tomorrow, the change or the future. So 90%. So we line that up with those that are happy today and those that are happy tomorrow. 10% of people who are happy today will be unhappy tomorrow. Right, now we could do this without being told that, because this column has to add to 1. So it's in line with happy today, unhappy tomorrow. 40% of people who are unhappy today will be unhappy tomorrow. So these people, we will have 40% of them still unhappy tomorrow. Okay, lining up there. Then 60% of people who are unhappy today will be happy tomorrow. So 60% of people become happier. Right, and that's our piece for the first question. And as it says, we would name that T. On a given day, out of 2,000 people, 1,500 or 1,500 are happy and 500 are unhappy. Write down a column matrix S0 that describes the situation. So we're after a column matrix that describes that situation. Okay, so it's called S0, and it would have to be in this form. 1,500 and 500. Okay, once we've done, we just need to identify it and make sure that we've got the rows in the same order in our state matrix as we do have them in the transition matrix. So this is our H and this is our U, or our unhappy. You can see here we've got H and then U. So when we multiply them, we're multiplying them by the correct values. So next up, we've done that. Describes the situation. The next day, how many of these people do we expect to be happy and how many unhappy? Okay, so I guess one thing to acknowledge is it's not asking us to show working out or anything like that, but the next day, if we're going to write it out as a recursion, we would have S0 equals 1,500 and 500, followed by Sn plus 1 is equal to T. So I'll put all these in this time. I'll just write the variable for it next time to save some time. Times our S0. Okay, so that will give us the answer on the next day. All right, so over here on the CAS, I've set it up already. Probably have to bring that into the screen just a touch. So I've set the matrices up already, and so to get the first one, we just need to go T times S, and we have S1 is equal to 1,650 and 350. All right. so that's C done. So key parts, that'll never change the matrix, the transition matrix, but every time we move up one, we will change this to Fn. So whatever the current state is, the current state for this one is S0. That's why we put it in there, and then that gives us 0 plus 1 to give us S1. Okay, part D, after 4 days, how many of these people do we expect to be happy and how many unhappy? So we can do this in a fairly short amount of time. We can do, I'm going to put in S, so I get my answer there. Then I'm going to do T times, so I'm going to do T times the answer. It's hidden there. Okay, so that will give me one of them. So you can see there that it's the same as previous S1. So that's S1, S2, S3, S4. Okay. So if we go to whole people, $1,713 and 287 is our answer. So it's still adding up to the 2,000 that we started with initially up there. If you had to do that another way and didn't want to use recursion, you could always use Sn equals t to the power of 4 times S0. That'll give you the same answer. That's just using the recursion there. And part E, last of all, in the long term, how many people do we expect to be happy and how many unhappy? Okay, so we need to pick 2 consecutive numbers for the transition, or 2 consecutive values of n for the transition. So we're going to use Sn equals, let's do t to the power of 60 times S0, and also Sn equals t to the power of 61. So consecutive numbers, and then we'll check out if they end up what we're after. If they don't, then we have to go higher than that. T to the power of 60 times S, and t to the power of 61 times S. Okay. So those two there are both giving us rounded figures to the nearest whole person, exactly the same. So we've achieved it. So in the long term, how many people do we expect to be happy and how many unhappy? So that will, if anything, it'll continue to go towards 1,714, and this will continue to move towards 285. Okay, but they right there to that decimal place, that's you can't get much better than that, because that's hasn't moved one bit. So in all, we get a state matrix that is equal to, so for S60, that's equal to, in whole people, 1714 and 286. Okay. So there would be happy people would be 1,714, and unhappy people comes to 286. Hopefully that's a reasonable explanation of that question. If you have any questions, wondering why I'm stuttering, pop them in the comments below. Like it, subscribe, etc. And we hope you are well. Cheers.